Hi, this is Anirudh, and in today's video we'll be talking about electrostatic potential as a part of electrostatics. Please do follow us on our Facebook, Instagram and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. For the first question today we have this. There's an electric field in x direction. If work done in moving a charge of 0.2 coulomb through a distance of 2 meters along the line making an angle of 60 degree with the x direction is 4 joules, then the value of the electric field is. So when we have a charge in an electric field, first step is to go for the force. The force we know is given by Q into E, that is 0.2 into E. I'm not keeping any units, we don't need that in MCQs. If the units are all in SI, you really don't need to worry about your units because they'll only slow you down. Next, we need to find the work done. That's what it says here. The general formula for work done is force into displacement into the angle the force and the displacement makes. All the three are provided to us. The work done is provided to us as 4 joules, so we put the values. The force we replace from this equation, 0.2 into E. The displacement is given as 2 meters into cos of theta. Theta value is given as 60 degree, so we put cos of 60 degree. Cos of 60 degree is half, so correspondingly 4 is equal to 0.2 E into 2 into half. We can cancel out this and this here. 0.2 goes with 4 and gives us 20. Therefore we get E is equal to 20 Newton per coulomb. So this is our first answer. For our second question, it says that the electric potential at any point x, y, z in meters is given by V is equal to 4x square. The electric field at a point 1, 0, 2 is, so we use the relation that the electric field is equal to minus of dV dr. Since the dependence of V is only on x, I can replace this in my case with E is equal to minus of dV dx. Putting the formula for V as given in the problem, we have d dx of 4x square. Differentiating 4x square, 4 being a common, comes out of the differentiation, so you have minus 4 d dx of x square. We use basic formulas of differentiation and we get differentiation of x square as 2x, so we can put the values minus 4 into 2x. Therefore E is equal to minus of 8x. Now we need a value of x. We have been given the coordinates 1, 0, 2. We are only concerned with the x coordinate because our answer demands x. So the 0 and 2 are insignificant to us for the problem. We put the given value of x into the problem, and that gives us minus 8 into 1. That is equal to minus 8 volt per meter. So fourth option is the correct option. As with our previous video, the third question is again a little tricky. I'll go through it. N identical mercury droplets charged to the same potential V coalesce to form a single bigger drop. The potential of the new drop will be. So for this question, we need to first find what the total charge possessed is. We know that the formula for potential for a spherical drop, in this case we know that it is a spherical droplet, is Q by 4 pi epsilon naught r, r being the radius of each smaller mercury droplet. Therefore, charge of each mercury droplet is 4 pi epsilon naught r into V. Now there are n identical droplets, therefore the total charge in our system, we'll replace it with a capital Q, is just n times of Q because there are identical mercury droplets. So the total charge is n times of that. So we have 4 pi epsilon naught r into V and n times of that. When they all coalesce to one single bigger drop, the bigger drop has to have the same volume as the sum of the volumes of all of them. That means if you are equating volumes, the volume of each smaller droplet is 4 by 3 pi of r cube. There are n such droplets, so the total volume is n into the volume of each droplet. We'll just call this the volume inequalities. This has to be equal to the volume of the larger droplet, because it's the volume of the smaller droplets that constitute the larger droplets. So if the larger droplet radius is capital R, it will be 4 by 3 pi capital R cube. We can remove the pi's, we can remove the 4 by 3's, and I have R cube is equal to capital R cube divided by n, or R is equal to capital R n to the power 1/3. Now we know that this larger droplet has a radius capital R, and it will have the total charge from the charge of all of these. We are doing law of conservation of mass and law of conservation of charge. So the larger droplet should have a volume, will represent the, should have a potential, sorry, will represent potential of the larger droplet with V dash, given by capital Q divided by 4 pi epsilon naught into capital R. We can put back the values, n into 4 by 3 pi r, n 4 pi epsilon naught small r into v, and down we have 4 pi epsilon naught, and capital R will be equal to r into n to the power 1 by 3. 4 pi cancels, 4 pi cancels, epsilon naught and epsilon naught cancels out, even r and r cancels out. You have v dash is equal to n to the power 1 divided by n to the power 1/3. That means n to the power 2/3, and the v remains as it is. So the potential of the bigger drop is n to the power 2/3 times the potential of each smaller drop. So our correct option is option 1. This is a very important problem for your JEE, especially this coalescing of droplets. This you may also face in capacitance, which we will cover in the next video. That's all we have for today. In the next video, we'll probably be heading into capacitance, and we'll be doing more sums on that. Thank you so much. Like, comment, and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.